Hello friends, once again very welcome to all of you. Today we have to discuss about concepts related to the mm, diagrams. First one is that there is a composite. In it there is indent that compose the objects in a tree structure to represent part or hierarchies. Composite lets clients treat individual objects and compositions of objects uniformly. There is a motivation, means graphics applications like drawing editors, schematic capture system let user build complex diagram out of simple components. The user can group components to form larger components, which in turn can be grouped to form still larger components. A simple implementation could define classes for graphical primitives such as text and primitives. Uh, Here there is a figure graphics. There are few methods there. There is a draw. In it there is a add, remove, and get child. Suppose that a graphic is line, rectangle, text, or picture. For that there is a method draw. That method draw have add, remove, and get child functionalities. If you want to call it, then we have to create the object, that is graphic G. It is called as a G dot draw. Then it will decide there is add, remove, or get child of line, rectangle, text, or a picture as shown in figure. So the key to the composite pattern is an abstract class that represents both represent primitives. Both primitives means their containers for the graphic system. That is class is graphic. Graphic declares operations like draw that specifies to graphical objects. It also declares operation that all composite objects share, such as operations for accessing and managing its children. The following diagram shows the uh, typical composite object structure of recursively composed gap. A picture, the picture has, there is a line, rectangle, or text, or line and rectangle. Applicability of this is, if you want to represent part whole hierarchies of objects. Dot, for you want to clients to be able to ignore the difference between compositions of objects and individual objects. Client will treat all objects in the composite structure uniformly. The structure is shown as in figure. This is the typical composite structure, might look like this, and the original structure of that is look likes as given in both figures that are represented. One represent the structure and second represent typical composite object structure, how it will be look. uh, so there are few uh, key elements there. There is a consequence, means composite pattern that defines class hierarchies consist of primitive object and composite object, makes the client simple, makes it easier to add new kind of component, and can make your design or general. The implementation of it is, there are many issues that are considered when implementing the composite pattern. First one is that explicit parent references. Second is sharing components. Third is maximizing the component interface storing. Fourth one is that declaring the child management operations, that is components of hash tables or list. 5 number is should component implementation, a list of components. 6 one is that child ordering. 7 number is caching to improve performance. 8 number who should delete the components. And 9 number what's the best data structures there. There are known uses, that is the RTL small tag compiler framework that uses the composite pattern extensively. Also related patterns to this composite, that is an abstract factory 87, the adapter 139 pattern. For that there is a bridge, that is indent decouple an abstraction from its implementation so that two can vary independently, also known as handle or body. The motivation is when an abstraction can have one server possible implementation, the usual way to accommodate them is to use inheritance. An abstract class defines the interface to the abstraction and concentrate subclasses implement it in different ways. But this approach isn't always flexible enough. Inheritance binds an implementation to the abstraction permanently, which makes it difficult to modify, extend, and reuse abstractions and implementations independently. So for that, consider the implementation of portable window abstraction in a user interface toolkit. This abstraction should enable us to write applications that work on both the X Windows system and IBM's presentation manager PM. For example, using inheritance, we could define an abstract class window and subclass X window and VM window that implement the window interface for the different platform. But this approach has two drawbacks. First drawback is that it's convenient to the extent the window abstraction to cover different kinds of windows or new platforms. Imagine an icon window subclass of window that specializes the window abstraction for icons. To support icon windows for both platforms, we have to implement two new classes, that is Xcon window and VM icon window. It makes client code platform dependent as shown in a figure. So bridge pattern addresses these problems by putting the window abstraction and its implementation in separate class hierarchies. There is one class hierarchy for window interfaces, that is window, icon window, transit window, and separate hierarchy for platform specific window implementation with window IMP as its root. The X window IMP subclass, for example, provides an implementation based on X window system as shown in figure here. Look towards that figure, you can understand it. And the last point of this is there is a applicability. Use the bridge pattern when you want to avoid the permanent binding between abstraction and its implementation. Both the abstraction and their implementation should be extensible by subclassing. Changes in the implementation of an abstraction should have no impact on clients, that is, their code should not have to be recompiled. You want to share an implementation among multiple objects. And last one, you want to hide the implementation of abstraction completely from clients. So friends, I hope that today you have understand the concept of so friends, I hope that today you have understand the concept of composite and bridge pattern. Thank you so much.